Okay, so 10.6 says exponential growth and decay, but this section is really what it's all worth, okay? Because these now are why we've learned everything about exponentials and logarithms. What we're going to be doing is working on word problems. And you're going to say, oh, I hate those, right? That's what my daughter says too. She's like, I just hate them. Words and math shouldn't go together. But this is why we've been doing all this stuff. And this is the most useful part of that logarithm stuff. So, at the top of your paper there, you have a whole bunch of formulas. Now, you're going to say, are you going to give me this chart on the test? And I'm going to say no, but I will tell you what formula to use. Okay? And I'm also going to go through and we're going to look at similarities between all of these formulas. So the first one just says growth and decay. That could be something like bacteria in a petri dish. Or it could be radioactive decay. Or it could be bunny rabbits, right? We've talked a little bit about bunny rabbit populations. So it could be something like that. It could be, no, not yet. But if you notice, the y is the ending amount. The n is the starting amount. E is that number we just talked about, that 2.7183. K is some sort of constant. If you have money in your bank account, that would be like your interest rate, or that would be your how many times the bacteria is growing in an hour, or something like that. And then T is time. Okay, so ending amount, starting amount, E, constant, time. Okay, well, continuously compounding interest. We use A equals P e to the RT. Those two are strikingly similar. Would you agree? Besides letters, we still have ending amount on the left-hand side. That's A. P would be the starting amount. So that's the money that you start out with. Okay? Grandma gave you $1,000. There's your starting amount. Does that make sense? Nice. Generous grandma, right? E, again, the number we just talked about. R is your interest rate. 0.25%, right? The thing with interest rate is I want you to think about them as the decimal version and not the percent. Again, T is time. Okay, so same thing. Ending amount, starting amount, E, rate and time. Appreciation of assets. What are things that increase in value the longer you hold on to them? Land, houses, gold, collector's items. Does that make sense? So appreciation of assets means it's increasing in value. Okay, well look, V is my ending value. What are you noticing about everything that's on the left-hand side of the equal sign? It's the ending value. P is my starting value. I bought a house for $50,000 40 years ago, whatever. 1 plus R, I'm increasing in value, so I have a plus sign. R is your appreciation rate. Again, that's as a decimal, not as a percent. N, I don't know why they don't do it as a T, but now N stands for time. Okay, if you want to change it to a T, that's perfectly fine. Depreciation of assets. Things that decrease in value. What are things that decrease in value as longer you own them? Car, right? As soon as you drive it off the lot. A computer. Money. Office equipment. A tractor. Does that make sense? Stuff like that. Shoes. I don't know. I don't know if you want to depreciate the value of your shoes. But anyway, right? So, look at what you notice. V is your ending amount again. P is your starting amount. He's decreasing in value, so I'm subtracting my rate, again as a decimal, and N is my time. All right, compounding interest. This would be if you get interest a certain number of times a year. Okay, so it's not continuously compounding your interest. They calculate your interest monthly or something like that, or every week, or once a year. Okay, so my V is my ending value. Again, P is my starting value. 1 plus R is my interest rate, again as a decimal. the number of times it's compounded, and I got cut off, but t is time. So how long it's going to be in your account. All right, now, do you see some similarities for all of them? Yes. The left side is always the ending amount. The right side always starts out with what you start with. Anytime you see a rate, it has to be as a decimal. So I'm not going to give you this part on your test. However, I will always tell you which formula to use. So you just need to know where to plug things. Does that make sense? I'll do it on your homework. I'll do it on your review. I'll do it on your test. I will tell you which formula to use. You just have to figure out where to plug it. If you get stuck, let me know, okay? All right, so the first one says, hold on one second, okay? Carl plans to invest $500 at 8.25% interest, compounded continuously. How long will it take for his money to triple? Okay, so let's figure out how much money is Carl starting out with? $500. Where does that go? Goes to the bank, right? But where in our formula does it go? P. There we go. How much money does Carl want to end up with? $1,500. Thomas.
What's the difference between compounding continuously and just compounding?
So compounding continuously means they keep calculating the interest. Does that make sense? Compounded interest, it'll tell you the number of times a year. So I calculate interest monthly. So that would be like 12 or whatever if you calculate it after a year. Does that make sense? Okay, E, we don't change E. My rate. This guy's as a percent, and remember I told you it had to be as a decimal. So how do I convert? Move it to the left twice, right? So this guy is 0.0825. And we want to know how long it's going to take for his money to triple. So we want to know time. That's what we're going to find out. Okay, so usually it'll be like years. Yeah, unless it tells you otherwise. Okay, so what do I have to do first? Is the E by itself? No, so I have to divide by 500. So 3 equals E to the 0.0825t.
Yeah.
What undoes an E?
Natural log.
Natural log. So we're going to take the natural log of both sides. Okay, so the natural log of 3 is 1.0986. The natural log of E will go away, and this gives me 0.0825t. Now what? Divide by 0.0825. 13.3165 years. It's not bad. He's also getting 8.25% interest, which is really good.
Yeah.
Because a savings account right now is like 0.25% of interest. Right? Carl, tell us your secrets.
Probably some like sketchy Scottish. Probably no bank.
It's on a cruise ship off the coast of China.
Will you tell us like what the unit of time is?
Most of the time. So like in number 2 here it says minutes. So we don't usually convert between units, so you won't have to do any unit conversions with time. If it doesn't tell you, then just assume years. Yeah.
You have to write it and just say T.
I'd like you to kind of give it a label. So T equals 3.3 years. I probably won't mark it off on your homework if you just tell me 13.3. Okay, you ready to try another one? So, number 2 says, a certain strain of bacteria grows from 40 to 326 in 120 minutes. Nasty. Find K for the growth formula. Use Y equals NE to the KT. Okay, so what's my ending amount? 326. What's my starting amount?
40.
Aren't they like the same formula?
Yeah. Pretty sweet, huh? It tells us to find K. I don't have to do any converting, so I'm going to leave that guy as 120. All right, is my E by itself? No. Okay, what do I need to do? Divide by 40. Whoa. .15 equals E to the 120K. How do I undo an E? Natural log. So I get 2.0980 equals 120K. Divide by 120. When you're looking for K's and rates and things like that, go ahead and leave them in 4 decimal places. That means that guy's growing at like 1.75% a minute. Does that make sense? So every minute he's 1 3/4% bigger. Okay, last one, number 3. A $40,000 car depreciates at a constant rate of 12% per year. In how many years will the car be worth $12,000? That's about where I am right now in my life. That's about what I have, and that's about what my car's worth. So use V equals P times 1 minus R to the N. Okay, so what's my ending amount?
12,000.
12,000. That's the value of the car after it depreciates. What did my car start out at? All right, what's my R? 0.12, right? 0.12 is 12%. Move it over twice, so that's 0.12. To the, we want to know N. You can put it to either if you want. All right, what do you think?
Divide by 40,000.
Okay, let's divide by 40,000. So I get 0.3 equals what'd you say, Griffin? 0.88, right? I can take 1 minus 0.12. Okay, so I get 0.3 equals 0.88 raised to the n power. Now what? What?
You have to do something.
We have to do
I
something.
just don't know what that is.
Is it the log? Is then the n comes down to the front?
Yeah. Does it have to be log base 10 though? No, we could do natural log, so it's totally up to you at this point. So, You don't see an E, but I need that N to come down out front with my log rules. So it's up to you at this point. If you want to do the natural log, you certainly may. If you want to do a log base 10, you certainly may. I'm going to do a plain log.
You get the same.
You do. Do you want to try it with natural log? See if they match? So I get log of 0.3 equals n times the log of 0.88. What'd you get, Harry?
I got 9.4.
9.4. I got 9.4216. So close enough for me. So in 9.4 years, my car will be worth $12,000. I feel like that's a little slow. My car's only 6 years old and that happened to me. Okay, so turn the page. There are 8 problems on this page. I gave you the formula for all of them. Okay? So all you have to do is do those 8 word problems. And then we're all done with chapter 10. Sound good, Wyatt? We're gonna have 3 chapters of trig after this. 3 chapters of trig.
A month and a half?
Yeah, trig's fast. There are only like 4 sections of these. Yeah.
That's really hard.